So this might be a good time for us to actually distinguish the difference between a function value and a limit value. We saw this a little bit in the previous video. These examples I know is saying to draw and explain two different graphs. If you are a visual person, feel free to do that, but for time purposes I'm going to go ahead and just write down some different notes about the two. So f of a is representing a function value, and this basically means that when you substitute in a, so if x equals a, what does the y value equal? Meaning you plug in a number, you get out a number, do you have a closed circle? The limit notation, though, that we're going to be using quite a bit this year, is asking us for a limit value, and this is about what are you approaching. So as x gets closer and closer to a, what does y approach? What is the y value getting closer and closer and closer to? So we're going to take a look about some table of values in these next two examples, and then we'll go ahead and look at some graphs to help us distinguish the difference between a function value and a limit value. So this table of value is representing an exponential function. And based off the table, we could probably draw what the graph would look like. Notice how negative values have high outputs, whereas some positive values have low outputs, kind of close around 1. So our exponential function might look something like this. So let's take a look at some limits. As the x's get very, very negative, so as we travel this way on our table, what do the y values approach? And notice how we're moving from 933 to 513. It looks like we're getting increasingly positive, closer to infinity. Let's go ahead and jump down here. Let's try the other side. As the x's approach positive infinity, so the further we go to the right on the table, it looks like the y values are getting closer and closer to 1. So both of these are kind of representing your end behavior. Notice how on the left-hand side the graph goes up forever, whereas on the right-hand side the graph is approaching 1. This is signifying that horizontal asymptote. Let's go ahead and approach some actual numbered values. So looking at b, we want to approach the x's as we get closer and closer to -3. Now this is an overall limit. Notice how there's no plus or minus sign in the exponent spot. So we're going to have to approach -3 from both sides. So as we get closer to -3 from the left and closer to the right, what do the y values seem to be approaching? So we go from 513 down to 33 down to 9. Whereas over here we go from 1.5 to 3 to 9. It looks like they're both approaching that 9 value from the table. We can do the same thing as we approach 1. Again, this is an overall limit, so we have to approach 1 from the left and the right, and it looks like the y values are getting closer and closer to 1.5. So exponential functions aren't too bad. We are going to step it up a bit and take a look at rational functions. So these are the ones that can have holes or vertical asymptotes in some spots, so we might be leery of those. Let's go ahead and give this one a shot. So as the x's get increasingly negative, the further we go to the left on the table, it looks like the y values are getting closer and closer to 1. Let's approach -1, but just from the left-hand side. So here's the -1x. As we get closer to -1, the y values are getting increasingly positive. Remember, this is a limit, so we're looking at what we are approaching, not necessarily what we're equaling. Okay, if we were equaling, it would be an undefined. But as we approach -1, we get very, very positive. Let's do the same thing from the right. So as we get closer and closer to -1 from the right-hand side, the y values look to be approaching something very negative. So that would be -infinity. So this is a good analysis of probably what's happening at this location of -1. So on the left-hand side of -1, we get very positive. On the right-hand side, we get very negative. But at the exact location, we are undefined. If we can think about that in terms of a picture, So let's see, -1 is undefined, but as we come in from the left, we get increasingly large. As we come in from the right, we get increasingly small. So this kind of looks like a vertical asymptote. And notice how we would be undefined at -1. So a little graphical thing here, we might be able to denote vertical asymptote at x equals -1. Moving on, let's go ahead and approach 2. So this is an overall limit. We have to check both sides. As we approach 2 from the left, notice how our number is 0.333. As we approach from the right, we have 0.334. So those numbers from the left and the right are extremely close together, meaning as you come in from the left and you come in from the right, they're practically meeting up. Okay, they are extremely close together. However, the moment you are 2, you are undefined. So it looks like we might have a hole there. Notice how the left and the right are really close, but the actual function value does not exist. So the limit, though, does exist because the left and the right side would match up, and that would probably happen at 0.333. Notice how the left and the right are very close to that value. So it looks like we have a hole at x equals 2 based off of that limit analysis. Moving on to the next one, as x approaches infinity, so we're going to make our x's get increasingly larger. Looks like the y values are getting closer and closer to 1. So the further we go to the right, the graph approaches 1, signifying a horizontal asymptote. And let's try this one. The limit as we approach -1. This is an overall limit. So we have to check both sides. I believe we already did that in B and C. And we even drew a picture of it. Notice how the left-hand side goes up, the right-hand side goes down. Clearly, the left and the right side do not look like they would be approaching or meeting up. So this must be a does not exist.